Hey, welcome to the Explainer. Today, we're going to peek inside the programmer's toolbox and unpack some of the super clever building blocks they use to create all the software we depend on every single day.
So, have you ever really thought about that? When you fire up a complex app or a massive video game, you're looking at something built from literally millions of lines of instructions. How in the world does one person or even a whole team manage to write all of that?
Well, here's the big secret. They don't. They don't sit there and write every single line from scratch over and over and over again.
What they do instead is use these really elegant, powerful tools that make the computer do all the heavy lifting. We're going to dive into 3 of their absolute favorites: functions, a mind-bending idea called recursion, and something called arrays. Okay, first up, let's tackle the biggest enemy of any programmer: doing the same thing twice. It's all about avoiding unnecessary repetition. Okay, so check this out. Imagine you're writing a payroll program. Now, don't worry about the exact syntax, just look at the pattern here. For each employee, you're basically doing the same steps. Now imagine your company has 1,000 employees. Are you really going to copy and paste that block of code 997 more times? No way. It would be a nightmare to manage. And this is where our first amazing tool comes in to save the day. Instead of repeating all that logic, we can package it up into something we can just call on whenever we need. And that package is called a function. The definition here is simple, but it's incredibly powerful. A function is basically a self-contained, reusable block of code that's designed to do one specific job. It's like a mini program that lives inside your main program. And you can just see the difference this makes, right? On the left, you've got all that messy, repetitive code. On the right, you have a single, clean, understandable line that just calls the function. This makes your code way shorter, so much easier to read, and, this is a big one, way easier to fix if something goes wrong. So, what actually happens under the hood when you call a function? Well, the computer does this little 3-step dance. First, it completely pauses whatever it was doing in the main program. Second, it leaves a little bookmark so it knows exactly where to come back to. And third, it jumps over to the function's code and starts running it. Once it's done, it just follows that bookmark right back to where it left off. Now, this right here is super clever. This is how the computer keeps everything neat and tidy. That purple box, that's the main program's memory, with its variables. But when it calls the function, the computer creates a totally separate private workspace just for that function, with its own variables. They can't see each other's stuff. This separation is a critical idea in programming called scope. Okay, so functions are fantastic for repeating a task. But what about problems that are defined in terms of themselves? For that, we need a tool that's a little more mind-bending. Get this. A function can actually call itself from inside its own code. This amazing concept is called recursion. It's a really powerful way to solve certain kinds of complex problems by just breaking them down into smaller, identical versions of themselves. Let's use a classic example, factorial. To calculate the factorial of 4, our function basically says, hold on, to do that, I first need the factorial of 3. So it calls itself. That new call then says, well, to get that, I need the factorial of 2. It keeps diving down this rabbit hole until it hits a super simple problem it already knows the answer to. Then the answers all get passed back up the chain to build the final result. Now, for recursion to work without just, running forever, it absolutely must follow 2 golden rules. First, you need a base case. That's a simple condition where it can just stop calling itself. Second, every single new call has to make progress, getting one step closer to that base case. If you forget either of these, you get an infinite loop, and that's bad news. So, should you use recursion for everything? Not necessarily. For some problems, a recursive solution can be incredibly elegant, just beautiful and easy to understand. But, and this is a big but, it's almost always a bit slower and uses more memory than a simple loop. It's all about choosing the right tool for the right job. All right, on to our final tool. This is the one that's going to help us tame all that data and finally solve our original salary problem for good. Say hello to the array. An array is really just a simple way to group a whole collection of similar items, like all those employee salaries, together under a single name. The computer then stores them all neatly in a continuous block of memory, one right after the other, kind of like houses on a street. And to get to one specific salary in that collection, you just use the array's name and its position number, which we call an index. Now here is the one crucial, kind of quirky detail that you just have to burn into your brain. Computers start counting from 0, not 1. So the first item is at index 0, the second is at index 1. It feels weird at first, trust me, but you get used to it. And this is where the magic happens. We combine our array that's holding all the salaries with a simple for loop. That's the part that tells the computer, hey, do this action for every single item in the collection. And just like that, we can process 1,000 or even 1,000,000 salaries with just a few clean lines of code. We've solved it. And here's one last piece of pro advice that's worth its weight in gold. You should always try to separate your code into distinct steps. One part for getting the input, another part for doing the processing, and a final part for showing the output. It keeps things so much cleaner and makes your code way, way easier to fix when something eventually breaks. So there you have it. We've seen how functions save us from repeating ourselves, how recursion can solve complex problems in an elegant way, and how arrays let us manage massive amounts of data. And these are really just the fundamentals. It kind of makes you wonder, right? What other ingenious tools are out there letting a few simple lines of code power the entire complex digital world we all live in?